Hey everyone, I'm going to make a quick video of the answer key for this practice based on Delta Math. I'm going to go quite quickly so you can pause and re-listen. Here we go. In this first one, select from multiple choice below the expression that's equivalent to 1 over 7 times x to the minus 5/4 power. Okay, there's some things to untangle here. I would say start with that negative exponent and move it up above. That exponent applies only to the x. It's PEMDAS that's grouping these by doing exponents first and then the multiplication, so do not move the 7 up. When you move that x to the 5/4 up, that becomes a positive exponent and the 7 is left below, down below. If they'd wanted you to move both up, they would have put parentheses around the 7 and the x, then you would move both up, but they didn't, so you don't. Then write this out of exponential form into its radical form, because our options are only in radical form. That's a 4th root right there. So there's the 4th root of x to the 5th over 7. That's this answer here. I've given you the reasons behind each of my simplifications, but you do not need to do that unless told to. I'm just doing that for extra review. Okay, so looking at this one, then we're given this equation. We can peel away the layers just like we do any math equation. We want to start with the outside and work our way into that x. This is the outermost thing. I add 29 to both sides and I get 7x to the 5/4 power is equal to, when I add that, 224. So what's the next outer layer? I'm going to work from the 7 to the inside, again because of PEMDAS. When I divide both sides by 7, I'm going to get x to the 5/4 equals 32. That's the division property of equality that gets me there. Again, you don't need to say that unless told to. I'm just putting that in for extra review. Then how do we deal with this in its exponential form? I'm going to, just like if there'd been a fraction out in front that I'm trying to get rid of, I multiply both sides by the reciprocal. Here there's an exponent that's a fraction, so I raise each side to the reciprocal power. That's where that 4/5 came from, because when I multiply these, according to my rules, they cancel and I get just plain old x to the 1, which I don't need to write. That's then equal to 32 to the 4/5 power, which I then carry over here. And I know that 32, if I were to make factor trees and break it down, it's 2 and 16 and 2 and 8 and 2 and 4 and then 2 and 2. And I would say, oh, that's equal to 2 to the 5th. So you don't get a calculator on the test, but you can break any number down and find its exponential form. So now I put that in there and then I just multiply these two and the 5's cancel and I get 2 to the 4th, which is 16. Again, the reason is I'm making a substitution, then I'm applying the power theorem, and then I'm just using the definition of what an exponent is to expand it. Delta Math likes it in expanded form. 2 to the 4th is also a good answer. Okay, next one then, what is 6 to the 3rd power raised to the 1/4 in simplest radical form? Well, for literally the third problem, that is just the root number, so it's the 4th root of 6 to the 3rd. If this had been to the 30th, you could take out batches of 4. Every 4 6's you have multiplying on the inside comes out as 1 6. So you would have, if it was 30 and you looked for dividing by 4, you'd have 7 6's that would come out. So you'd have 6 to the 7th power outside, and you'd then have 2 leftover 6's on the inside, if it had said that. Okay? On this one now, express in simplest radical form 81x to the 1/4. Again, that's a radical number. 81 can be written as 3 to the 4th power. So when you bring in that 1/4, the 4 and the 1/4 cancel out, and you're left with just x to the 1/4, which is the 4th root of x. Okay? I wish there'd been a little bit of variety and had some 1/3 or 1/2 powers, but there you go. Now on the back side, then it's just simplify the following expression to the simplest form using only positive exponents, so no negative exponents. Again, bring in that exponent as an exponent to the 32. Once again, that's 32 is 2 to the 5th, so the 5 will cancel with that 32. When you bring the 2/5 into the 25, again, the 5's will cancel. You bring the 2/5 into the -5, and you'll get, each of these will cancel with the 5s, and you wind up with 2 to the 2 to the 2nd power is 4. Then you get x to the 10th power, and you get y to the -2, which then goes down below, and that's your final answer. Getting close to the end here. These are both 10 raised to some fractional exponent when you untangle it. Again, there's the root number. It's not 4 this time, it's 5, so it's 2 over 5, 5th root. Here's 6. That's the end of lunch. 6th root down there, and you've got 10 to the 5th power up above. Now all we do is add these fractions, so you need to find a common denominator, and you wind up with 37 over 30. Again, you don't need a calculator, you just need to go slowly and carefully, and you got it, and it's this option right here. So multiple choice makes it a little bit easier, but sometimes you have to just be careful not to switch your numbers around. Okay, so now it says use the properties of exponents to determine the value of a for this equation. So you can see here I've rewritten it in given form. What have I done here? I've taken this out of radical form like we've done so many times. I've rewritten it. Again, that keep stressing, that's the root number, so that goes down below. That's the exponent number, so that goes up above. And now all I need to do is combine these, and that is the product theorem of exponents, that you add those exponents when you're multiplying a product. Then I can say, well, they're both to the same base x. If it's an equal base, then those exponents must be equal. And then I just clean up the math, and I wind up with 34/5. You could write it as 6 to the 4/5 power, or even 6.8 for example, and that would be okay too. There are the steps. Hopefully that helps. Oops, sorry about that. I didn't show it all. I'll get it all on camera for you. There's the last step. Good luck, everyone.